Okay, so now let's take a look at this problem. Find the length of the curve, the cardioid. R equals 2 times 1 plus sine theta, or 2 plus 2 sine theta here. Okay, so we can draw it. So theta equals 0, so it's going to be 2, right? Theta equals pi over 2 is going to be coming to 4. Theta equals pi, this is going to be another 0 in this direction, right? And when theta equals 3 pi over 2, so this part going to be -1, so it's 2 minus 2 times negative, or 2 plus 2 times -1 is going to become 0. So basically the cardioid, okay, again, not good at drawing, but you will see it's going to be something like this. Okay, so that's kind of like a very bad drawing. So it's from 0 to 2 pi. And to find the length of the curve in polar coordinates, the formula is going to be from beta to alpha to beta square root of r squared plus dr d theta squared, and then d theta here. Okay. So we're going to work on this problem here. So r is here, and then we can calculate our dr d theta. That's going to give us is a 2 cosine theta here. Okay. And then we can plug in. So this is going to be from 0 to 2 pi. This problem going to be extremely long. Okay, guys. So so it's going to be 2 plus 2 sine theta squared plus 2 cosine theta squared d theta. Okay. And alright, so we can start to do simplification. It's going to become into 4 plus 8 sine theta plus 4 sine square theta plus 4 cosine square theta, and then d theta. So this part equals 4, so it's going to be 4 plus 4 is 8. So it turns out this is going to be 0 to 2 pi square root of 8 plus 8 sine theta d theta here. Okay, so now so I didn't expect this problem is that complicated in the very beginning, but turns out it is. Okay, so starting from here, what you need to do is you're gonna need a couple of properties. Okay, so so first of all, keep in mind is you know that sine theta actually equals cosine of pi over 2 minus theta. Okay, so that's kind of like a super basic trig identity. And there is another trig identity here is cosine of theta. It actually equals 2 times cosine square of theta over 2 minus 1. Okay, minus 1. So basically what we'll do here is we're gonna use all this trig identities to simplify. Basically what we did is we're gonna do into 2 steps. So you can see that for here, if we let theta, sine theta equals cosine pi over 2 minus theta here, And then so this part becomes into 8 times this. So basically this is what I mean. It becomes into 8 plus 8 times cosine of pi over 2 minus theta, and then d theta. And then after that, we gonna need this friend, okay, to help us. So you see that cosine theta equals this. So cosine of pi over 2 minus theta gonna becomes into cosine 2 times cosine of pi over 4 minus theta over 2, right? And then minus 1. So this is becomes 8 plus 8 times. So for so it's 2 cosine square. It's going to be half, right? So it's a pi over 4 minus theta over 2 square, and then minus 1. Okay, minus 1. So after we do that, you will see, and then don't forget this d theta, you will see that the problem, if we simplify one more, so it becomes into, you say 8 times 2 is 16, right? This is square. And also you have 8 times minus 1. So it's minus 8. 8 minus 8 is 0. So inside it's going to become into 16 cosine square pi over 4 minus theta over 2. Okay, so this is minus, and then d theta. So it turns out we can even bring this out into a 4. Okay. So that's what we get so far. Okay, that's what we get so far. And now, so the problem becomes into 4, 0 to 2 pi. And you can see that, guys, when you have a square root and a square, like if you try to simplify them, you need to be very careful, because you need to put as cosine of pi over 4 minus theta over 2 absolute value, and then d theta, because we don't know if the value of this part is going to be positive or negative, okay, or negative, you know. So so it turns out that, so up to here, most of the problem part is going to be done. And so the next step, what you need to do is you need to make a U substitution. Okay, so if we set U equals pi over 4 minus theta over 2, so keep in mind that you're going to have du is equal to negative half d theta. Okay, half d theta. And also you're going to have, you're going to encounter a new lower bound and new upper bound, right? So you see when theta equals 0, so when theta equals 0, u equals pi over 4, right? Minus 0. And then with theta equals 2 pi, u equals pi over 4 minus 2 pi over 2. That gives us as negative 3 pi over 4. Okay, negative 3 pi over 4. So if we do a U substitution, you know, from here to here, what we'll have here is, so after the U substitution, you're going to have is 4. So it's from pi over 4, right, to negative 3 pi over 4. Absolute value of cosine of u, and don't forget this part of d theta, right, is going to equals to negative 2 du. So it's going to be negative 2 of du. So that's how do we solve this problem here. So up to this stage, what we get is going to be negative 8 integral pi over 4 to negative 3 pi over 4 absolute value of cosine of u du. Okay, that's what we get so far. almost there. Okay, guys. So yeah, this is it is a complex problem. So you know, when we learn the integrals here, we would like to let our lower bound is smaller than our upper bound. So under this situation, what we can do is we just you know, multiply the negative, so things will reverse. So it becomes into 8. So negative 3 pi over 4 to pi over 4 absolute value of cosine u, right, du. Okay, so it's a okay, so that's what we get. Okay, that's what we get. Now there is also a slightly tricky part is you know, if we would like to shift the bound of the integration by pi over 4 so that the absolute value of a cosine of u have the same sign throughout its region of the integration. Okay, so this can be done because the region of the integration spans exactly 1 period pi, okay, and it contains exactly 1 zeros of the absolute value of cosine u here. So basically this part is a little bit tricky. So this integral actually is going to be equivalent to from negative pi over 2 to pi over 2 absolute value of cosine u du here. Again, we're gonna shift the bound of the integration. So shift bound of integration I plus a pi over 4. Okay, so that we can make sure that absolute value of cosine you have the same region. Okay, and then turns out that when we have this value from negative pi over 2 to pi over 2, this cosine u is going to be, so cosine of u is going to be greater or equal than 0 when u is between negative pi over 2 to pi over 2 here. So this integral drops into cosine of u, right, du here. And then all the rest part should be super straightforward. So this integral is going to be 8 times sine of u, right? And then integrated from negative pi over 2 to pi over 2. So it's going to be 8 sine of pi over 2 minus sine of d pi over 2. So this is 1, this is negative 1. So 1 minus negative 1 become a 1 plus 1. So it's 8, so 1 plus 1. So we got our answer is 16. Okay, so again, this is, it is a very comprehensive and a little bit tricky problem. So I hope you enjoy this video. Thanks.